So today we'll be discussing about some of the numericals on stress and strain. So first of the numerical, which you can see that it's example 1, which a question says about a circular road of diameter 16 mm and the length is given 500 mm subjected to a tensile force. So first of all, we have to understand that there are two different type of forces. Basically, we already explained, that is, if a force acts outward, that is called tensile, and if a force is acting inward, and it is called compression. You have to understand. And the sign convention for tensile we consider it as a positive, and for compressive consider it as negative. These are the two basic concepts. So now in questions already it has been mentioned that a tensile force of 40 kilonewton has been given. The modulus of elasticity for steel can be considered as 200 kilonewton per mm square. Find stress, strain and elongation of the bar due to applied. So the question is very simple. So already in question it has been mentioned that load has been given as 40 kilonewton. So when you convert kilonewton, so you have to multiply with 1000, so that comes out to be 40 into 10 to the power 3. So it is here. Okay. Now when you see modulus of elasticity is given as 200 kilonewton per mm square. So because we have converted the load in newtons, so you have to convert again that particular kilonewton into newton, so we have to multiply with 10 to the power 3, and the dimensions of area has been considered in mm square, so no need to worry about that, we can leave it as it alone. So other dimensions is mentioned that you can see the diameter is 16 mm. So when we consider a circular, when we consider a particular rod circular cross section, so it means that the area of cross sections will be circle and area is equal to pi d square per foot. So when we consider diameter is given, pi is constant, so you can calculate the value in terms of particular mm square. So what we have to calculate out now, next thing is that we have to calculate, basically see question, it is mentioned that you have to calculate stress. Stress is what you know, load upon area. So simply load is given, area is given, you can calculate. Next is you have to calculate strain. So what is strain? What is strain? So strain, you know that change in length upon original length. And elongation of bar, you have to also calculate it. So see how the question has been solved. So when we see first part is that we have to calculate stress. In most of the cases you see in book, symbol used is sigma. So sigma equal to P upon A, P upon A, so it comes out to be Newton per mm square. Again, strain basically when you consider about, when you study Hooke's law, so it says that modulus of elasticity is equal to stress strain. So sigma upon strain, basically when you consider, it can be termed as small e. So strain equal to sigma modulus of elasticity. Sigma is given, modulus of elasticity is given, so we can find out the value of strain. So it does not have unit, so it comes out to be this particular value, 0.000994. You can also cross verify with your calculating results. And the next thing is elongation. So elongation already I told you, because basically what happens when you find out this particular formula, so sigma equal to P by A and delta L upon L. So this is what delta L upon L, and this is sigma is equal to P upon A. So when you convert this particular, so you will get that delta L equal to P capital L small l A. So P is load, L is length, A is cross section area, capital is modulus of elasticity. What is P? P is load, which is in terms of kilonewton. So what is L? L is the length of the bar. What is A is the cross-sectional area. In this particular question, a circular rod has been given, and when you consider capital E, so capital E is modulus of elasticity. It's very clear. I think it's very easy to solve this type of problems. You have to understand the value of load, you have to have the value of length, you have to have the value of cross-sectional area and modulus of elasticity. So most of the time what happens, the student gets confused with particular this E. So unit may be in terms of, let's suppose here the unit was kilonewton per mm square. So you can have basically in terms of megapascal, or sometimes you can have also in terms of gigapascal. So in that case we have to multiply 10 to the power 6, basically 10 per meter square. This will be 10 to the power 9 Newton per meter. So simple is that you have to convert that particular value, whatever is given, it is, if it is in megapascal, so you have to multiply with 10 to the power 6, and when it is in gigapascal, so you have to multiply with 10 to the power 9. So I think the question will be very easy, and you have to also understand the concept that in this particular problem the load was tensile. So what will happen, let's suppose in this case a question could have been asked that, let's suppose the load is of basically if we apply particular, this is a particular bar, and when that load could have been in compressive direction, so the same will be the result, will be the final result delta L can be negative, because when we consider the sign convention, so compressive force is considered to be positive. So that is the one of the difference. So now I will move to the next questions, and that I will do on the basis of the strip bar. So it is very important concept. So see, these type of problems are very important and relevant. So in that case what you have to understand, let's suppose this is a stepped bar. So in this case you can see the section 1, section 2 and section 3, and the nature of load is that the both loads are balancing each other. So the problem is, such type of problem will be equilibrium problem, means both forces are neutralizing each other. So in that case, let's suppose P is acting outward and this P is acting outward, both are of tensile nature. So the problem is of equilibrium condition. In this case what we have to do, simply we have to draw the, basically we have to consider, let's suppose individual member 1, 2 and 3, and accordingly we can solve the total change in length, or let's suppose extension, whatever in problem is given. In this case basically the area is changing. Initially area is A1, next one is A2, next is A3. Simultaneously the length are also changing, L1, L2 and L3. So see, and in this type of problem, what are the basic concepts which you have to apply? So first of all is that you have to draw the free body diagram. So in this case it is very important that the force which is acting at this will be neutralized by the other section. Similarly the force acting this will be neutralized by section 2, and the same force will be acting to neutralize section 3. So in this problem the forces remains same, that is P. So P will be equal, first of all you have to understand P will be equal throughout the entire section, entire different section. So whatever we select. So in this case when you see the problem, so first of all you will consider, let's suppose you have considered the portion 1. So portion 1 in this case you can not sigma 1, and this is particular strain, so by default you will get the value, and you will also get the value of delta 1, that is extension. Similarly sigma 2 can be calculated, strain also can be calculated, and delta 2 we calculate, because in this problem only length and area is changing irrespective, because in this case we are also considering the material is same, in this case. So what will happen, modulus of elasticity will remain, this concept will also apply. Apart from that what will happen, now see sigma 3, when you consider the value of sigma 3, so it will be P upon 3, the strain will be P upon A3 into N, extension will be like that, PL upon AE. So in this case in throughout the problem what you have studied that length and area is changing. Length and area is changing. However, the load remains same. Load remains same throughout the particular section. As well as we have also considered the material is also same, so modulus of plasticity also remains same. So whenever we complete, so in this is such type of problem, what is required, you have to find out the total change in length, or you have to find out basically the change in length of the bar. So that will come, that comes to be summation delta. So delta 1, delta 2, delta, it can be delta L1, delta L2, delta L3. So it can be written as PL1 upon A1E. So when you compare this particular equation, so P is constant, E is constant. So what will happen? Now you will get the value L1 upon A1, L2 upon A2, L3 upon 3. So this gives you the final result of total change in length. So such type of problems are very easy to understand, but what is the main thing in this particular topic? You have to understand the value of P, that P is in under balance condition, so P will remain equal throughout the section. And the second concept is that the length and area gets changed. So in this such type of problem where varying cross section is given, you have to simply just calculate the value of P by E, and you can calculate L1 I1 and you multiply with this particular total component, you get the final value, that is total change in length. So this such type of problem is very easy to understand. You can see the example. When we consider this example, so in this case, in this particular problem, it is seen that a particular bar, or let's suppose a rod is given, which is tested in UTM machine. The purpose of UTM machine is to test the tensile strength or compressive strength or CS. You can also check out the particular value. So already I have explained the concept of stress and strain, how to plot the diagrams, and what are the particular important points which we infer from mild steel or cast iron diagram. It is observed that a load of it is particular, the total extension of bar is given, determine the Young's. So in this case problem is very simple. There are three sections. First, when you consider second as well as third. Now it has been the material, they don't have, the question does not speak about the type of material, but however, because similar material is used, we can consider or we can assume that material is same throughout the particular section. So Young's modulus of this particular section will also remain same. So one of the concept is that you have to assume the material is same of three different sections. So yes. Now extension, you know the formula P into L1, because this is the balance condition, because since the load is acting equal and opposite, so this is under the equilibrium condition, and you can assume that the previous numericals which I have explained, in that case what was happened, the load was equal, and accordingly you have solved the total change in length. Similarly, you have to calculate the total change in length. You can consider that P upon E remains constant, L1 upon A1, L2 upon A2, L3. Yes, so in this case, if you consider length is given, L1, L2, L3. So length is given. Accordingly, area you can consider, because since the diameter is given, so what will happen? The cross sections comes to be pi d square upon. So diameter is given, you can calculate out area. So you can calculate, already length is mentioned, length 2 is mentioned, length 3 is mentioned section. A1 you can calculate, A2 calculate, A3 calculate. Get the value of this particular P upon E terms this. So P is given, already in question it has been mentioned 40 kilonewton, so you can apply the value. And the total extension is given in basically mm, so this value is given, so you can calculate the value of E, modulus of elasticity, that is Young's modulus. So it is very easy problem. You can see this question already, the value of E comes out to be 200,990 Newton per mm square. So this is the final value. Now we'll be doing some certain problem which is basically a concept of not tapered, but I will consider the example of in which consider variable value. Let's see, drop this problem. The problem of, just let me draw. So consider basically a bar or a rod. Suppose this is a rod which has three different segments. This comes to be A, C, B, C, and D. And what we consider force, let's suppose this direction is 60, this direction is T, this direction you T, this direction you consider 50 kilonewton. So all the units are kilonewton. So it's such type of problem where let's suppose there are different forces acting at the different surfaces. So in that case, in such type of problem, what you have to do, you have to draw, let's suppose their length is L1, length is L2. Similarly, let's suppose their diameter can have D1, D2. In such type of problem, either you have to calculate the total change in length of a bar, delta L1, or you have to calculate basically the strain of individual sections. Individual section you have to calculate. So in that case, already in question there may be a given that E equal to, let's suppose 20 into 10 to the power 9, 10 per meter square, the value of a particular modulus of elasticity of particular material. So in such problem, what is required, first step is to draw the activity body diagram. So what is free body diagram? Since you are saying that there are different sections, first of all, let's suppose when you see that is A, B, B, C, and C. So always start from the problem from left side and move to right side. This is the correct attitude. So when you see the problem, that is section AB, so I take this particular blue. So AB, first of all, you have to do the free body diagram, that is 60 kilonewton, let's suppose force is applying. So to counteract, what will happen in balance condition, there must be a force which is of opposite 60 kilonewton must be acting at particular point surface this. Now what is happening for section, let's suppose B, and this is A, this is B and BC. So let's suppose C already 60 Newton is acting, so you have to balance this 60. Now 30 kilonewtons is acting in downward direction, basically in reverse direction, not downward, it's inward. So 30 kilonewtons. Already explained you that tensile need to be considered as positive, compressive need to be negative. So what will happen? So when you see the value 60 is positive, 30 is negative. So 60 minus 30 comes to be 30 kilonewton. So 30 kilonewton is the resultant of this, which is outward. So outward 30 kilonewton. So to balance this must be also outward. Now see the problem, the section D. When we consider section D, so what happened? 30 is on it outward, so there must be a balance force of 30 kilo. Now at this particular surface, when you say C, 20 kilonewton is outward. 30 plus 20 comes to be 30 plus 20 comes out to be 50, and 50 must be balanced, which is already given at section D. This is 50 kilonewton. So such type of problem is very easy. You have to understand that for a section A, the load or P is 60 kilonewton. For section B, C, the value is 30 newton, 30 kilonewton, and for the section you consider CD section, the value for load is 50 kilonewton. The only thing is that here what is happening, the load is different, P1, P2, P3 is different. You know the formula, delta L equal to delta L1 L2 L3 summation P into P1 L1 A1 upon modulus of elasticity constant, P2 L2 A2 B, P3 L3 A3E. What will be E is constant in question already, it has been mentioned. E is given, that is 20 into 10 power 9 Newton per mm square, or meters. You can convert, if either it is in meter square, you have to convert it to mm square, or let's suppose length will be also given in mm, diameter will be also given, so you can consider in mm square Newton per. What is required right now, we have to apply the value of P1, we have to substitute the value of P1 L1 A1 and E, P2 L2 A2 E, P3 L3 A3. Substituting the value, you will get the net change in length of the bar. So this can be a, I hope whichever the concept I have given, I think you can use it to solve any type of problem which is of a step bar or step rod. In this particular problem, a circular cross section can be given. In another problem, there can be a section of a square section. So there will be area, whatever the area can be different, that is L square. So in that case, the section will be in terms of length. Basically, they will give you the data of the replacing diameter with the length. So you have to multiply L square, L into L. So in that case, the if the section changes, maybe it's square section. So in that case, the area changes, the formula changes. Remaining concept remains same. Whatever I have given you the concept does not change. So in such type of problems, you have to calculate. Basically, the main concept is you have to find out the load with the help of this particular free body diagram. And once you calculate the free body diagram and corresponding load, the problem is very easy. You can substitute and you can get the results. So I hope everyone have got the point and you will solve this particular problem. Thank you. We'll meet in next class.